Hi all, we all know about Pythagoras theorem. It's nothing but a squared plus b squared equal to c squared. And here a being the altitude, b being the base and c being the hypotenuse of a right angle triangle. Now an interesting question, from where did I get this equation? How does this a square plus b square become c square? And that is what we're going to see now. For that, let's consider a small right angle triangle. And I'm placing it here and I hope it's straight. Okay, so I'm having a right angle triangle here, and let's say the base being the b here and the altitude being a here, and this side being the c, that is the hypotenuse. B is the base, a is the altitude, and c is nothing but my hypotenuse. And let's consider 4 more rectangles or 3 more rectangles exactly like this, and we will form a small square by using that. So here we are having 4 similar triangles forming 2 squares here, one being the inner square, one being the outer square. Now how did I understand that I'm having 2 squares here? Okay, I can see it, but how do I know that? And it is self-explanatory itself, because the inner square having all the sides as the hypotenuse of the triangle here, it's all nothing but the hypotenuse, and the outer square, and I know that this is a, and then this should be b itself. If this is b, then definitely this should be a, and if this is a, this should be b, and this is b, this should be a, and this should also be b. Now if I add them, I'm having here a plus b, here also a plus b, here also a plus b, here also a plus b. From that I can understand the outer figure is nothing but a square itself. Now let's fit a small square inside this empty space. I'm having a small square with side c being fit into that empty space. Now I want to keep this idea in your mind. I'm forming a square of side a plus b, and I'm having an empty space inside it, and the area of that empty space being c square, because the square inside it is having a side of c. Keep that idea in your mind. Now let's take this square out of this figure and place it just below here. And remember this one, what was the area of this particular square? It was nothing but c square, since one of the side was c. So I'm having a square there as c square. Now let's rearrange this entire triangular pieces. So yeah, we have rearranged the right angle triangles, and after rearrangement I'm having 2 new empty spaces, the one here and the other one here. So there I can actually fit 2 more squares. Let's say I'm fitting on the small area this smaller square, and on the large area I'm fitting a larger square. Now let's consider the edges I'm having here, and this is nothing but what? This side is nothing but b itself, and this is nothing but a itself, because this is a, and this have to be a because this is a, and since this was b, this has to be b, and this also have to be b. So I'm having exactly the same square I had on the previous case, that is a plus b. It is the same square, but I'm having 2 new empty spaces. One empty spaces was nothing but this square, and the other one is nothing but this square. And this square is having an area of a square, and the other one is having an area of b square. Since I'm having the exact same square, isn't the empty spaces should be equal to c square itself? Yes, exactly. So that means I can pull this first or the smaller one from this one and put it here, and I can pull the larger one from this one and put it here. And I know that the first one, that is nothing but a, and their area is nothing but what? A squared plus the second one, which is having an area of b square, and that is equal to c square, and hence the Pythagoras theorem is proved.